Flash pyrolysis is an excellent tool for the analytical chemist. To perform flash pyrolysis, there are three different technologies available. Filament, which uses a coiled wire. Curie point, which employs a ferromagnetic foil. And vertical microfurnace, which utilizes a low thermal mass ceramic furnace. Vertical microfurnace technology guarantees reproducibility. The sample is protected in an inert cup, held at near ambient temperature in helium gas flow, and is not subjected to heat prior to pyrolysis. The microfurnace is heated to the desired temperature, which is precisely measured with a thermocouple sensor, located next to where the sample will be pyrolyzed. The sample cup then drops into the quartz pyrolysis tube, where the sample is rapidly and reproducibly pyrolyzed. Accuracy is obtained because the pyrolysis is consistent each and every time. The pyrolysates are directly swept onto the gas chromatography analytical column for separation and detection by a mass spectrometer or any other detector. This single-step process of the microfurnace allows low and high molecular weight, as well as polar compounds, to be detected and analyzed. The direct connection, with the absence of valves and transfer lines, is critical to the ability to detect heavy and polar pyrolysates, as well as additives. Filament and Curie point pyrolyzers are known to suffer from poor temperature accuracy and poor reproducibility as a result of non-uniform heating. In both systems, to avoid condensation of the pyrolysates, the sample must be inserted into a heated manifold prior to pyrolysis. This preheated step has the potential to cause denaturation, degradation, or thermosetting of the samples prior to analysis and may result in poor reproducibility. Some filament pyrolyzers use a two-step process in which some of the pyrolysates are first collected on a trap. A switching valve is then used to send the pyrolysates from the trap through a long line into the gas chromatograph mass spectrometer. During this two-step process, polar and heavy compounds may cause cross-contamination or be irreversibly stuck in the trap or the long transfer line and are not transferred for analysis because of the potential of cold spots in the system. Flash pyrolysis, also known as single shot, is the fundamental technique for polymer analysis. Vertical microfurnace technology performs true flash pyrolysis, where sample introduction is instantaneous and heavy and polymeric materials are reproducibly broken down into smaller fragmentations called pyrolysates. The optimum pyrolysis temperature is obtained from the evolved gas analysis thermogram, as we discussed in the method map video. To perform flash pyrolysis, the evolved gas analysis tube, or EGA tube, is quickly and easily exchanged with a separation column without venting the mass spectrometer. The vertical microfurnace is programmed to the desired pyrolysis temperature, and the analysis proceeds. So, what is it about Frontier's vertical microfurnace technology that gives such a superior result? 1. With a direct connection to the GC injection port, no transfer lines, all pyrolysates are inertly transferred in a single step onto analytical column as they are generated. The full range of light, heavy, and polar compounds are placed directly onto the column. Nothing is lost, giving you superior results. 2. The sample, placed in an inert sample cup, is held at near ambient temperature and is not exposed to any heat prior to the analysis. Also, the sample is purged of oxygen before heating, so there are no oxidation reactions. Therefore, there is no chance of evaporation, degradation, or thermosetting of your sample prior to analysis, giving you superior results. 3. By controlling the actual sample pyrolysis temperature to within plus or minus 0.1 degrees centigrade, the Frontier low thermal mass microfurnace technology guarantees accuracy and reproducibility, again giving you those superior results. The next video in this series shows how the vertical microfurnace technologies perform double shot and heart cutting using Frontier's different modes of operation.